Hello. Today's topic is Earth's exterior. We're going to look at weathering, erosion, the sediments that make up our crust, the soil. This image here is kind of an interesting thing. You have a erosion-resistant boulder, and then underneath it you had looser sediment, and so differential erosion led to these monuments and goblins that we find throughout the southwest desert area. Erratics are boulders and rocks that don't belong. Many times they've been moved by glaciers, but however this particular rock got there, you can see that the soil underneath it was a little more compact due to its weight and more erosion resistant. The external processes that shape the earth are weathering and erosion. Mass wasting is just a huge erosion event, but those are the processes that shape the earth. This is a great picture from Marathon Beach down in the Florida Keys. That's called honeycomb weathering. The limestone bedrock is dissolving in the water, leaving these pock-like honeycombs. They are really cool. Fish, crabs, chitin, and all different little critters live in the temporary pools during low tide and then can move around during high tide. So it's like a little fishbowl setup. The two types of weathering are mechanical and chemical. We'll start off with mechanical. The primary process is abrasion, but this is breaking down the rocks physically. So thermal expansion, freeze, thaw, weathering, unloading, and biological activity all can mechanically break down the rock. This is more prevalent in the colder climates. The chemical weathering is the breakdown of rock due to chemical change, water, oxidation, other factors more prevalent in the warmer climates. You can see the marble and the limestone is showing weathering in the cemetery. So the older the tombstones or monuments are, the more weathering that they show. Carbonic acid, the reaction of water and carbon dioxide forming a weak acid, causes these limestone and other dissolvable rocks to dissolve. They're the reason for many of the sinkholes that we have in Florida. We have the soil bacteria creating a weak acid in solution, and then we get the sinkholes. Oxidation, the formation of rust and other oxides, is a common form of chemical weathering as well. Living things also produce acidic compounds, tannin from tannic acid from leaves in the mangroves, or citrus trees drop their leaves, and these chemicals also can break down the soil. So the rates of weathering, how fast it happens, determined by the rock composition. That goblin displayed slower and faster weathering. The climate, and then human activities. Soil is very, very important. I took an entire semester class on soil. So you think it's dirt, but it's very important because most of our food is directly related to soil. Soil has three phases: solid, which generally speaking is the rocks and minerals, and then organics. Some precipitates also. Liquids, the water and the soil solution, and then the gas is oxygen. You can't forget the oxygen. In very water-bogged soil, you tend to get root rot. So you have to have all three phases for a soil to be healthy. So here's a look, the chemicals, the solid chemicals from precipitation, the regolith, the solid minerals and liquid chemicals, all make up soil. So soil can be transported. like down in the Mississippi River Delta from all over the country, or it can be residual, formed exactly where it was made. Now, erosion is what transports the soil. In the case of the Mississippi River Delta, it's obviously the Mississippi River. You can have windswept soil or other agents of erosion. The organic matter is generally found on top. Litter is not broken down, and then humus is broken down and generally on top or in the topsoil. The texture, we generally have sand, silt, or clay, sand being a little larger than silt, and clay being microscopic. So mixtures of sand, silt, and clay, sandy soil, silty clay, loam is a good mixture. That's the most healthy mixture we have. The soil triangle here used by the USDA is how we classify the soils. You get the percent of each size particle and you use it to classify. In labs, they use sieves or sieves. I prefer sieves, and shake, separates out the particles by size, and then you analyze the soil sample. Soil forms in layers, and the older the soil, it's generally deeper. The layers are called horizons. Climate plays an important role in soil formation. Thicker soils tend to prevail in warmer climates. And of course, vegetation also plays a major role in soil formation. Topography also. Steep slopes tend to have more erosion. So the soil horizons, we term the soil profile. O is the organic, what's on top of the soil. A is the topsoil. E is the layer where the chemicals build up, the alluviation layer. B, subsoil, tends to get rockier. C, the regolith, and then D, the bedrock. So you get rockier and rockier and rockier as you go deeper, and you find less biological influence as you go deeper as well. Arctic soils tend to be really thin, so they're missing some of the horizons. Desert soils, a little different as well. This is just the general categorization of soil layers. The link there you may get to by the unvideotaped PowerPoint shows you the 12 types of soil according to the USDA. Porosity and permeability are related to the amount of airspace and water flow that can be found in your soil sample. Porosity is pore space, permeability is how fast the water moves through. So erosion is the movement of soil solids, generally downslope. The agents are wind, water, or ice. So running water is the most common worldwide. In arid region, winds play a big role. And then glaciers play a big role as well in the colder regions. We need to prevent the loss of soil. The picture there is showing these contours with the slope and strips left between plows to stop the flow of water. So the Great Depression is famous for the Great Dust Bowl, the soil erosion, and we really depend on healthy soil for our lives. So the image below shows exposed roots, soil erosion. 80% of our world's agricultural soils are negatively affected by erosion. And sedimentation clogs our waterways. Eutrophication, which is the buildup of nutrients due to erosion also clogs up our waterways. The consequences of eutrophication are explosive algal blooms. This algae dies, causing anoxic conditions, killing off wildlife and stagnating the water. Mass wasting, avalanches, landslides, and such is huge erosional events. The image there is a landslide that occurred in the Smoky Mountains in Tennessee. In Florida, we have a topography that is termed as karst, which is a German term. It is a landscape shaped by the dissolution of limestone and other carbonate-based rocks. Sinkholes, either springs when they're full of water or caves when they're not, are a common occurrence here in Florida, and that is due to our karst topography.